Before we get into the wounding profiles of different weapon systems, it's useful to consider some of the physics of what's happening when a projectile is fired out of a weapon and what happens when that projectile hits its target. When a projectile leaves the barrel of a weapon, it leaves with what is known as its muzzle velocity. So the velocity it's traveling at as it leaves the muzzle of that weapon. And there's two main factors that will determine this muzzle velocity. The first factor is the amount of gunpowder or propellant that's in the bullet that accelerates that bullet out of the barrel of the weapon system. And the second factor that determines muzzle velocity is the mass of that projectile, how heavy it is. Now, not all bullets are created equal. So in smaller caliber weapons like handguns or submachine guns, you have less propellant through to larger bullets that are fired out of military style weapons like AK or M4 that have more propellant, all the way through to your heavy machine guns like your 50 caliber that have more propellant again. Once the projectile has left the barrel of the weapon system, it follows a parabolic trajectory. So it starts to get impacted by forces in the environment, these main forces being the effect of gravity, pushing the bullet down towards the ground, and then the air resistance. As the bullet moves through the air, it's pushed against by the resistance of that air, which serves to slow it down. So as the bullet travels further and further along this parabolic trajectory, it gets slower and slower because of this air resistance. Once it's left the barrel, the projectile is stabilised in flight by two main factors. The first factor is what's known as rifling within the inside of the barrel of most weapon systems. And what this does is it's curved spiral grooves that engage the bullet as it travels down the barrel and start it to spin while it's in that barrel. So when it exits the barrel of the weapon system, it's spinning in flight. And this serves as a stabilizing force. It's kind of like when an American football is thrown, it spins, and there it's stabilized in flight because of that spinning motion. The second factor relates to the shape of the bullet. So most projectiles are pointy at the front or more pointy at the front and flat at the back. And so what happens as that projectile cuts through the air, the forces of that air moving over the projectile help to stabilize it in flight while it's traveling at high speed. As the bullet slows down, either it reaches the end of its trajectory or it starts to slow rapidly if it's hit a target, it tends to destabilize. So those forces that help to stabilize the bullet in flight are no longer present, they've changed, and the bullet starts to destabilize and undergo a process known as yaw, often referred to as tumbling. This yaw or tumbling effect is caused by the shape of the bullet. So when we look at a standard projectile, we can see that its center of mass, so the midpoint of the mass of that projectile, is further back than the halfway mark. So as that bullet starts to slow down, it loses those factors like the spinning and the air pressure that stabilize it in flight. As it starts to slow down, it destabilizes and the center of gravity wants to flip around and start to travel forward. So as a bullet slows, it will start to destabilize, yaw, and then eventually it will tumble so that the back end of the bullet is traveling at the front of its trajectory.